Welcome everyone. Today we're gonna explore the fundamental of integral and calculus. So by the end of this tutorial, you'll understand the basic integral concepts, solve an integral step by step, and apply it to the real-world problem. So first of all, what is integral? In simple terms, integration is the reverse of differentiation. It helps us to find areas, volumes, and accumulations in real-world application. So I'm gonna ask you, are you ready? Because I'm ready. Let's go! So first of all, what is integration? So basically, integration is a process of finding a function whose derivative is given. It's also used to compute the area under a curve. We have a symbol of integration. We call this symbol as an integral. So we have a components of the integral. We have the integral of f of x dx, where the f of x is a function and the dx is a small change in x. Okay, since you already know the symbol of the integration and its constant, I'm going to explain to you next the indefinite integral. So first, I'm going to explain to you the indefinite integral. An indefinite integral finds a function whose derivative is the given function. It includes c, the constant of integration, because integrating removes differentiation's effect, which could have included in any constants. So example of the indefinite integral, the 2x dx. So we should use the power rule. So the power rule states that the integral of x to the power of n dx is equal to the x to the power of n plus 1 over n plus 1 plus c. The integral of 2x dx.
So we put 2x because 2x is our x. Is equal to 2x to the power of 1 plus 1 over 1 plus 1 plus c. Simplifying the expression, 2x squared over 2 plus c is equal to x squared plus c. So we come up with the final answer, x squared plus c.
So this is the example of the indefinite integrals. So since we're already done at the indefinite integral, we have next the definite integral. The indefinite integral finds the area under the curve between 2 points or limits. It gives a specific numerical value instead of a function. So we have the example here of the the definite integral. So this represents the area under the curve of 2x from x to 1 2x is equals to 3. So the indefinite integral of 2x is found using basic integral rules of the integral of 2x dx is equal to x squared plus c. Since we are dealing with a definite integral, the constant c is not needed. So we evaluate the results as the upper limit is x is equal to 3 and the lower limit is x is equal to 1. At the upper limit, the x is equal to 3, we have the x squared is equal to 3 squared equals to 9, and the lower limit we have the x is equal to 1. So x squared is equal to 1 squared is equal to 1. So subtract the lower results from the upper results, which is the 9 minus 1 is equal to 8. So the value of the definite integral is 8, which represents the exact area under the curve between x is equals to 1 and x is equals to 3. At the objectives, I put there the real life application. That's why I choose the integration in 6. So to find displacement, we integrate the velocity function over the given time integral. So this means we are calculating the area under the velocity curve from t is equal to 0 to t is equal to 2. So the integral of 3t squared follows the power rule of integration of the integral of t to the power of n dt is equal to t to the power of n plus 1 over n plus 1. So applying this rule to 3t squared, we have the integral of 3t squared dt is equal to 3 times t to the power of 3 over 3 is equal to 3 cubed. So the antiderivatives of 3t squared is t cubed. So applying the limits, the fundamental theorem of calculus, now we evaluate the functions t cubed at the given limits t is equal to 2 and t is equal to 0. So substitute the upper limit t is equal to 2. We have the 2 cubed is equal to 8 and the 0 cubed is equal to 0. So we subtract the upper and the lower limit. We have the 8 minus 0 is 8 is equal to 8 units. So the total displacement of the object from t is equal to 0 to t is equal to 2 is 8 units.
Hey, it's me again, and that's all for our topic for this video. And we have the summarization for our topic for this video. We have first the integration versus differentiation. So this means that when we integrate a function, we find the original function before it was differentiated. Integration and thus differentiation. The second is the power rule is used for polynomial functions. So the power rule states that the integral of x to the power of n dx is equal to x to the power of n plus 1 over n plus 1 plus c, for n is not equal to negative 1. So this rule makes it easy to integrate polynomial applications, polynomial expressions. So lastly, the third is application in physics and the real-world problems. Integration is widely used in physics, such as finding displacement from velocity, computing areas under curves, and solving real-world engineering problems. That's all.